Hi folks, it's Mr. Defy once again. Welcome back. In this video, I will be showing you how to solve a system of equations, but unlike the last two videos about this that had to do with graphing and substitution, this video is about how to use what's called the elimination method. And elimination is exactly what it says. It eliminates. It's a process of getting rid of things that you don't need or want at a certain time. As an example, if we have negative 3 plus 3, the result is 0 because they eliminate each other. The same thing with 5n take away 5m. They both eliminate each other, they make a 0. Our goal with the elimination method is to try to create a situation where, as you can see in example 1, a situation where either our x's eliminate or our y's eliminate. And in order to do this, they have to be exact opposites of each other. So in example 1, where we have to solve if it's possible, what we have to do is we have to examine both types of variables and then decide whether or not one is ready to eliminate or not. And if it is, then we go ahead and do it right away. So let's take a look at, first of all, our x's over here. Our x's, we have x and positive 2x. Now, if I were to combine these going in a vertical downward direction, x and 2x would not eliminate. They would actually create a 3x. Now, that is nowhere close to elimination. That's actually creating more than what I had in the beginning. So I'm not going to go with the x and 2x. I'm going to look at my y's instead. If I look at these, I have to notice, first of all, the signs are both opposites of each other. Here I have a negative y, whereas here I have a positive y. And not only that, but their coefficients are negative 1 and positive 1. And that's good for me because what that tells me is that they will eliminate each other when I combine going vertically. So this will be my focus and method for example 1. So in eliminating them, all I have to do is cross these out, and that shows that they have become a 0 and are no longer present in my, my system of equations. And that gives me free range to go ahead and combine whatever is left, which is my x and 2x and my 11 and 19. So doing that gives me a 3x over there, and over here I get a 30. Okay, now this leaves me with a one-step equation that I can solve mentally. 3 times a number is equal to 30. What number is that? Well, the only number it could be is a 10. But if you want to be very thorough and show our work, then we would divide by 3, and we would get x is equal to 10. Now this is only half the answer, because I need to get my y component, since these answers, all of them, if there is an answer at all, what they represent is a common solution or a point of intersection between the lines made by these functions. So if I have an x value, I need to have a y value as well, and vice versa. So our next job is to get the value for y. And we're going to use our value for x as leverage to do that. Remember that because it represents a point of intersection, it doesn't matter which equation you choose to get the value of y. Each one will give you the same answer in the end, so it really depends on what you are most comfortable working with. In this case, I'll go ahead and use the first one. So x minus y is equal to 11. Since our x is 10, this will go in there. And so what I get now is I get 10 minus y equals 11. And solving this, and I'm going to move a little quickly here, negative y equals, this is 1. The opposite inverse property goes there, and then what I get is y is equal to negative 1. So putting this together as a whole answer, what I get is my common solution happens at 10 and negative 1. Here's example 2. And in example 2 you can see that it's a little different from example 1, because unlike example 1, where we have a clear opposite terms, y and negative y, Here in example 2, we don't really have that. We do still have x's and we do still have y's. That will never change. But if you look at the x's over here, we have a -2 and a -4. Now, a couple of things about that. The negative and negative are clearly not opposites of each other. Second thing is that you have a 2 and a 4, which is very different from having a -1 and a +1. So right away I know that I cannot eliminate these x terms with each other. Now, if we look at the y's, it's kind of the same thing in a way. So I still have two negatives, and that means I cannot eliminate them because they need to be opposite signs. But the thing that is different with these y's compared to the x's is that I have 2 9s, and that means that when it comes down to choosing which variable to eliminate, the x's or the y's, it might be easier to actually eliminate the y's. And here's why. Here's why. The reason is that all I have to do to eliminate these two terms with each other is turn one of these -9s into a +9. Now, doing that is simple because in order to make this, for example, into a +9, all I would have to do is multiply this with a -1. And just like that, it would become a +9. But here's the thing. Each of these terms in that equation are linked together like links of a chain. So whatever you do to one term automatically affects all the terms equally. So I can't just multiply the -9y with a -1. I have to multiply the -2x and the -25 as well. So going ahead with this and organizing my work better, this is what we get. So I'm going to show my work over here that I'm multiplying with a -1, okay, with the objective of turning this -9 into a +9. That's my goal. So here's what we get. So -1, and I think I'll do it like this. I'll show it like this. So it's actually times -1 times -1 times -1. Okay, and what we get is the following. We get -1 times -2x is +2x. -1 times -9 is +9y. On the other side, -1 times -25 is +25. Okay, so this is now changed from what it was before. This bottom equation, however, remains unchanged, and I just simply slide it over to the right, and I rewrite it under this. So -4x, there's my -9y, and my -23. So watch what happens. See, now that these are both exact opposites of each other, what will happen is that they will eliminate with each other. Okay? And when they're not there anymore, that gives me freedom to go ahead and combine straight down over here and straight down over there. And so what I would get is -2x minus, 2x minus 4x is -2x. 25 minus 23 is simply regular 2. And if I use the division property and I divide, what I get ultimately is that x is equal to -1. Okay, now this is, again, only half my answer. To get the other half, which is my y, I need to take my previous answer, which is the -1, and decide which equation I want to substitute that -1 into. And again, it doesn't matter which one, because regardless of the equation, they each represent a line which meets at a single point. And that location is what we're trying to define here with our answer. So we have half of it already. In fact, I'm going to go ahead and start putting our common solution here. So our common solution thus far is -1, comma, I don't know. And it's that I don't know, that question mark, that output, or my y number, which I'm trying to now figure out. So I'll take the -1, and I think, they're both about the same. So I think I'll go with the first one. So we're going to use the first equation. Here's what we get. Negative 2, instead of negative 2x, I will have negative 2 multiplied by negative 1, which is the answer that we just got. Okay. Again, it's the answer we just got a moment ago. It's now right there. And then, switching to my other color. And then, so it's negative 2 times negative 1 minus 9y equals negative 25. Now, if you notice carefully, I only have one type of variable here to solve for. So that makes this work super, super simple. From here on, it's simply the rules for solving equations. So this is now positive 2 minus 9y. And then if I subtract 2 on both sides, I get negative 9y is equal to negative 27, which, when dividing by negative 9, means that my y is positive 3. And that means my unknown is now known. This 3 goes in here, right there. And just like that, I'm finished. So this is our common solution. Or, in other words, our point of intersection. If you were to graph these two lines, you would see that they intersect at negative 1 and 3. Okay, so I've given you 2 examples. I do have a third one coming up, but you'll have to watch for my next video after this one. Please stop by, check it out, leave a comment anytime. All comments are welcome as long as they're constructive. And I hope to see you again very soon for the follow-up video to this with example 3 on using the elimination method. Thanks for watching.